So moving on from that, we looked at the different components of prompts, some of the best practices. Now I'm going to talk about a few more advanced techniques when it comes to prompt design and prompt engineering. So certain models always expect a specialized prompt structure. We saw, right? GPT-4 models, it requires a system message. Then you have examples. The example should have a user message and then what the assistant's response is. But when it comes to like a normal GPT-3 models, like where you can ask a question and it will provide you a response. So while we have the principles of prompt engineering that can be generalized across different model types, but there are two distinct APIs where prompt engineering comes into play: the chat completion API and the completion API. Each API will require the input data to be formatted differently, which in turn is going to impact your overall prompt design. Keep in mind, like any new applications that you are creating using the OpenAI models, you will be using the chat completion API because the GPT 3.5 Turbo and GPT-4 models, they use the chat completion API, which is what Microsoft is recommending you to use. Chat completion API and completion API. Chat completion API, it supports the GPT 3.5 Turbo and GPT-4 models. It can take the input formatted in a specific chat-like transcript stored in an array of dictionaries. So the array of dictionaries are nothing but providing a system message, then the user and assistant message. So let me quickly pull that through to recap your understanding when I say what does that really mean. So if you take this chat playground, if you go and take this Xbox customer support assistant example, so as you can see, there is a system message. There is examples that we are applying, which has got a user message and an assistant message. This is what a typical prompt structure for a GPT-4 model. And that's what I'm talking here about. So when you use the GPT-4 model, this is what exactly the prompt structure is all about. And this is what we call it as an array of dictionary because I have a system message. Then within examples, each example will have a user as well as the assistant message. With the completion API, it is supported in the older GPT-3 model. So this is not something that is supported in the new models. It is in the older GPT-3 models. And why do you need to know about it? Because sometimes you may have some early adopters, right? There are some customers who have already used the GPT models and they may be using the older version of the models and they haven't upgraded to the GPT-4 models yet. In those type of scenarios, it is good for you to understand how the prompts that you have to apply for the older GPT-3 models, which is basically text in and text out. And that's what you are learning through this. So this is what a GPT-4 model is expecting in terms of what should be the prompt structure. You pass a system message, you pass an example which comprises of a user and the assistant message. And the system message is normally included at the beginning of the prompt and it is used to prime the model with the context, instructions, and any other relevant information for the use case that you are dealing with. And of course, like you can use the system message to define the assistant's personality. In the example which we saw, right, we said behave like an Xbox assistant. So that is basically setting the context for that chat interface to say, now I have to behave like an Xbox assistant and have to answer the questions. And basically you can define instructions around what the model should and shouldn't answer, what should be the format of the model responses, all in the system message itself. So always make sure that when you are creating the system message, you provide some clear instructions, exactly what you're asking the model to do. And also it's nothing wrong to repeat the instructions at the end. I said like it's okay to repeat the instruction at the start, then you put some primary content and then you can also repeat the same instruction at the end. By duplicating the instructions, of course, like you will be, the tokens will be doubling up, but also sometimes it sets the context really well and clear for the models in terms of what is the response that they need to provide. So it's okay to do that. So don't worry about like, okay, is it okay to repeat the same thing multiple times or not? And prime the output. Exactly tell like what are you looking for. So if you look at this example, which I've got on screen, like the system message basically says it's an AI assistant, which helps people to find information. And here, if you look at one particular information it is adding is answer in as few words as possible. So you are restricting the model to say don't keep on writing sentences and sentences, just keep it precise and simple, and that you can specifically mention. So you can just prime the output exactly what you're looking for, saying give me the response in bullet points or give me the output in JSON. So these are some instructions you can give the model exactly how you are looking the output for. Always add clear syntax for your prompts, like the punctuation, the headings and things. So sometimes it is really good if you provide that. So as I said, but also keep in mind that when you're using punctuations, like how you can handle things in terms of managing the tokens, right? So that is something to keep in mind. And also use the triple dash here like as a stopping condition for generation, so that it knows like you have completed it, you are just waiting for the model to provide responses. So you can use separators like that between multiple sources, saying oh, this is the first section, this is the second section, this is the third section. So if you want to segregate them, of course, like you can use those triple dashes in there. And try to break the task down. So if you break the task into smaller steps, then the large language models, they will perform better. So if you look at it like you can just instruct to say, this is what I want you to do instruction wise. This is the paragraph of information, which is the primary content. And then you can provide some additional factual claims, the queries that you want to ask the large language model. So you can just segregate them into different sections, which is going to make the large language models to perform in a better fashion. So this is a chain of thought example. So when it comes to prompt engineering, right, you ask a question, you get an answer, but sometimes you will be more curious to know how did the model arrive at that answer. So let us take this a simple mathematical problem, right? Roger had 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. And how many tennis balls does he have now? So he had 5 already. He buys 2 more cans. So each can has got 3 tennis balls. So which means total of 6 tennis balls. So if you add what the previously he had 5 and now he has 6, you add them, you come to 11. So chain of thought processing is when you ask that question, the model can just say answer is 11, but you are more curious to know like okay, how does the model arrive at that answer. You can ask for that in your prompt itself, saying I want to know the chain of thought process. Then automatically it is going to say Roger started with 5 balls, then he had 2 cans of 3 tennis balls, then each is 6 tennis balls, the total is 11. So it is showing how it arrived at the answer 11. And sometimes this information is really important. So these are what you're seeing on my slide is some examples where how it has applied the chain of thought processing, the models applied the chain of thought processing in order to arrive at that response. So you can ask for it, and of course you can get that straight from the models. The another prompt engineering technique is prompt chunking. So prompt chunking is basically a process of breaking down complex information into smaller and manageable units. So you may be wondering, right? So for instance, like I have a 40 or 50 page document, which I want to summarize it. So there is a 50-page document which has got heaps of text. If I try to put all the things into the prompt, I will run out of tokens in scenarios. So depending on the limitation I have got, the number of tokens I can use, I'll run out of my tokens in there. So how do I better handle that? By prompt chunking technique. So you can take that 40-page document and you can chunk them into separate prompts. Multiple times you may need to call the model. That is the one thing. But again, we can mitigate that using batch processing. We'll talk about that later. So you chunk that prompt into 4 or 5 different prompts. Each you can take portion of the text and summarize it each time. And that is what we call it as the prompt chunking. And normally like you will apply this technique, especially like if you don't want to go beyond your token limit, but still you want the ability to chunk them. So then you will join all the pieces together whatever the output you are getting, and that's what you can apply as a prompt chunking technique. So this is another technique that you can apply, especially if you don't want to go more than the token size. The next technique is specifying the output structure. So here, when you are using your prompt, you can always specify the structure of the output that you want, because that can have a significant impact on the nature and the quality of the results. So for instance, you can, in the system message, you can say only write true facts. Don't give me fabricated information. And you can also say to the model, like, give me the information in like a JSON format, or you can also instruct the model to say, give me the source material from where you got that information from. So you can ask any of these things as part of the prompt, and basically like you are dictating what should be the output structure that you are looking for from the model. And that's a good practice, because if you ask for it, the model is going to provide that information. There are two parameters when it comes to the large language model, how you can fine tune them in order to get your desired output. They are temperature and top underscore P parameters. So temperature parameter is basically like you can change the temperature parameter, which changes the output of the model. You may be wondering around, where do I go and change these things? So if you go to your chat interface here, on the right hand side here, you can see parameters, right? So here you can see the temperature parameter, which is basically controls the randomness in the responses. And you have the top underscore P. So this is also control the randomness, but it uses a different method based on the token here. But here this is going to be based on like how the model will provide the responses on the input that you are sending. So this is based on token. This is based on the inputs that you are sending. So when it comes to temperature, the lower the temperature, then it is going to be more accurate. So if you keep the temperature value really lower, the response is going to be more accurate. If they keep the temperature the higher, the responses will have more randomness. So then your question is, why should I have a temperature that is high? Because it's going to give random answers, right? Think about your writing a fictional story. So which means you have to be more creative. It doesn't need to be realistic fact or anything. It can be random, right? So those, for those type of scenarios, right, you can go for a higher temperature. But if you are reviewing a legal document or something, make sure the temperature is really low. So if you want accurate responses from the model, keep the temperature as low as possible. And we are talking about between 0 to 0.2. So the actual range is 0 to 1. So if you use 0, 0.1, 0.2, then you can tailor it as more accurate. But if you use zero point 0.7 and above, then there will be randomness in your responses. So you can control the temperature parameter in that way. Same thing with top probability. Make sure, like if you are using top probability, again, it will control the randomness with your responses. The key part you have to keep in mind is don't use both the parameters at the same time. So the general recommendation is, if you are using temperature, alter the temperature only, because otherwise you will confuse the model. Either you alter the top probability or you alter the temperature, but don't alter both at the same time in your chat interface. So that is something to keep in mind. The next part of prompt engineering is providing grounding context. So always provide some grounding data for the models, because one of the efficient way to provide reliable answer is to give the model data from where it can get the responses. One of the technique that we are going to talk as part of tomorrow's session is around how do you augment your organization data to the large language models. And when we talk about that, we will be using the technique where you will be providing the grounding data for the model to respond from your own organization data. And we will talk about that technique in detail in tomorrow's session. But just keep in mind, like you can provide grounding data from where the answers will be provided by the large language model. So we talked about like the system message sets the context of your chat interface, right? There are other things that you can set as part of the system message. The first thing is like you can define specific tasks in there. You can define how the model should complete them, what should be the scope and the limitations, what should be the posture and tone. So tone is like you can specifically say to the model, when you're providing the response, always provide the response in a softer tone. Otherwise, like you don't want the model to respond to you in a harsh tone, right? And also like you can define the language and the syntax, the styling and the formatting of the responses. You can also describe difficult use cases. You can also identify and prioritize the harms that you would like to address. So let me show you an example, right? Because I talked about a lot of these things, but you need to think about how do I put all these together to design a prompt. Before we get into that example, just quickly look at these two things. One is we don't provide any guidance. So here we just said a human and a computer are having a discussion. That's it. And then you are asking a question and then it is providing a response. If you look at the type of question that you're asking, like the human is asking, why are you upset at me? The computer is saying, I don't know what you're talking about. The human says, no, you clearly are. Tell me why. The computer says, I'm upset because you didn't listen to me when I told you that I wanted to try out for the team. So this is overly aggressive tone. So sometimes when you are having a chat interface, it can be with your customers, right? So you don't want to go in an overly aggressive tone. So as you can see here, okay, this is something that you have to just do in terms of like why you don't want to be overly aggressive and you want to just make that to be kind. So here is the meta prompt that you can write where you can make that chat to be more kind. So here we are starting the message itself like saying you must be kind and seek common ground. Try not to repeat your responses. And here the human and computer are having a discussion. So here you can just say like you have to be really kind. And so you say, what are you upset? And then you can say like, okay, I don't know what you're talking about. I want to know why you are upset. So if you can see the tone here, it is a bit more kinder tone than what you saw here, which is more aggressive tone. That's what we call it as a meta prompt. So which means you can add additional information to the prompt about the behavioral attributes, the safety guardrails, the examples that you want to provide, the output format you want to provide. So if you add all these things, so your prompt can have all these details. You can define the profile capabilities and limitations. You can define the output format. You can provide examples to demonstrate intended behavior. You can define additional behavior and safety guardrails. So these are all the things that you can provide as part of the meta prompt. And this is just a simple example of a meta prompt template for a retail company chatbot. So that's what we are seeing in here. So now you understood, right? So pretty much what I have been walking you through for the past 40 to 45 minutes is around what are prompt engineering techniques, how to write good prompts, and what are the key prompt components, and how do you make sure like you follow the best practices when you are writing prompts. And we saw that with a variety of examples. But I wouldn't just say like, okay, you attended my session for this 45 minutes and I will say you are an expert in writing good prompts. It doesn't happen like that. You have to put that in practice. So make sure that you practice writing prompts, multiple prompts, and making sure like, okay, whether the prompts are giving the desired output from the model. And that's how you will learn how to write good prompts. But these techniques and best practices will guide you to write good prompts.